In this video, we want to compare the regular operations of real numbers and compare it to those operations with matrices. Okay, so we've already have seen in the previous page, addition is commutative. So commutative means like the order doesn't matter, right? A plus B is equal to B plus A. So yes, it's commutative. Multiplication, we already know, is also commutative since the order doesn't matter. I can multiply A times B and it's the same as B times A. But what about subtraction? So what you should ask yourself is it true that A minus B is equal to B minus A? And of course the answer is no, right? So this would in fact give us the exact opposite value. Similarly, what if I divide in the other order? A divided by B, and I'm using the fraction notation. Is that equal to B divided by A? And of course, no, usually that's not true. I mean, occasionally, if A and B are equal, then yes, it's true, but in general, that's not true. What about matrix A plus matrix B? Will we get matrix B plus matrix A? And the answer is yes. We've already seen how this happens, and that is because the actual way that we add matrices really is term by term, just regular real number addition, right? So it will be the same. So matrix addition is commutative. What about matrix multiplication? Well, as again you should have just read in your e-textbook or on the previous page we saw for the notes, it is not always the case that AB will equal BA. So matrix multiplication is not commutative. All right, let's look at the next property for what about associativity? Associativity is basically talking about how we group the terms. Does it matter if we group A plus B and then add C, or if I add A and then group B and C together? And for addition and multiplication, the answer is it doesn't matter which way I use parentheses. So let's ask ourselves, what about if I did A minus B and then I subtract off C? Is that equal to A minus, in parentheses, B minus C? And right away, if you are being careful and notice that if you're to subtract this quantity B minus C, then actually when you subtract by distributing, this C will become a positive. So the answer is no here, that subtraction is not associative. It matters how we parenthesize these things. You can't just make it all, these aren't the same thing. Likewise, if I divide A divided by B and then divide it by C, we could ask ourselves, is that equal to A and then divided by B over C? And the answer is going to be no, that those aren't the same, because if I actually want to divide this fraction, it's equivalent to, this would be A times C over B, because I'd be multiplying by the reciprocal, right? So this one over here would be A divided by B times C, both in the denominator, and here the C is in the numerator. So no, division is not associative either. Matrix addition, is that associative? So if we add A plus B and then add it to matrix C, is that equal to A plus matrix B plus C? And the answer is yes. And again, that's because of the fact that the way we define matrix addition is really solely based on real number addition. So yes, that would be true. What about matrix multiplication? If I multiply A times B times C, will it equal A times B times C? And I think at this point we actually haven't officially seen this yet, because I don't think you've had the opportunity to do that. So I think for right now, actually I'm going to pause it for a second. Okay. Sorry, yes, I did just double check. I forgot that you did just see this, property on the previous page. So you do know that matrix multiplication is associative. So this one is a yes. Okay, so the distributive property it's sort of a weird property. In the previous page, when we were looking back here, they sort of combined addition and multiplication. It's sort of one way of thinking about it. But what we're really talking about when we were talking about distributive, we're talking about distributing multiplication across something else, right? So multiplication can be distributed across addition, right? So if I multiply A times, in parentheses, B plus C, of course, this is what you usually think of as just the distributive property. And we wouldn't have an equivalent thing for distributing multiplication across multiplication. That's sort of just the associativity property. So we don't talk about multiplication across multiplication in either of these boxes. But what about the distributive property of multiplication across subtraction? So is A times B minus C going to equal A times B minus A times C? And of course, yes, that's true. What about if I take A and try to distribute across B divided by C? So the question is that A times B over A times C? And of course, no, that's not true, because of course this would just be equal to B times C. So the distributive property of multiplication does not go across division. What about matrix addition? Can we multiply A times B plus C and get the same thing as A times B plus A times C in terms of matrices? And again, I'm looking back at our notes. That was, in fact, something that you talked about in this previous page. So yes, it is distributive across matrix addition. Okay, moving on. For identity, we have to be careful here, a little bit more careful than what the previous page did in their table. So the additive identity, so because we're in the addition column, the additive identity is 0, because 0 is the number that if I can add it to A on either side, right? A plus 0 is equal to A, and 0 plus A is equal to A. And it's going to matter that we're talking about both sides here in a minute, you'll see. Okay, so the additive identity is 0, because you can add 0 on either the left side or the right side and get the same thing. And likewise, the multiplicative identity is 1, since again, you can multiply 1 on either side of A and still be left with A. So the question is there a subtraction identity? And so what we're really looking for ourselves is there some A minus something that will give us A? And so at first you might think it's just 0, but it also has to be that something minus A also gives us A. So if we chose 0 here to be the identity, then we see that 0 minus A isn't going to give us A. So in fact, no, there's no identity here for the subtraction. What about division? If I take A and divide it by some number, can I get A? But also have that same number be that when I divide it the other way around, I get A. And the answer is no. You can't come up with a number that will do that for any given A. What about matrix addition? So is there some matrix that I could add, so A plus something that gives me A, and also have that same thing that when I add it, I still get A on the other side? So this, I believe, you have not heard about yet. And so we're going to eventually learn an identity. We're going to probably call it I believe is what your e-textbook does. So we'll have to talk about what that matrix looks like. But in fact, actually, let me pause the video for one more second here. Sorry. Okay, sorry about that. So no, actually, in fact, your book uses I for the multiplicative identity. So the identity, additive identity is just going to be the 0 matrix. So what is the 0 matrix? Well, it is whatever dimension A is, but with all zeros in it, right? So if we add a matrix of all zeros, of course, on either side, you're just going to be back with the original matrix. So matrix addition does have an identity, and it is just the 0 matrix of whatever size you're working with. Okay, finally, matrix multiplication. So again, this is the one that your book calls I. So we're going to have to sort of stay tuned for this. There is a matrix I that when you multiply it on either the left or the right, you can get back just the original value of A. So stay tuned for a future video about that. Okay, finally, inverse. This is a long video, I apologize. All right, inverse is what do you have to do to get back to the identity, right? So since 0 is the identity, we're trying to get back to 0. So for addition, you want to add the opposite of the number. For multiplication, you want to get back to 1. So you want to multiply by the reciprocal of whatever number you started with. And again, you have to be able to do it on both sides in order for it to be the inverse. So since there is no identity, there's nothing that you can sort of get back to, right? So automatically these are both a no. For addition, we're asking ourselves, what could we add to A to get back to that 0 matrix? But it has to be that same thing. When I add it on the other side, it gets me back to that 0 matrix. So in fact, this is going to just be like the additive inverse for real numbers. We have this sort of idea of the opposite of A, which would be to just take all of the terms in A and make the signs opposite, right? So this would be like a scalar multiplication by a -1. So every matrix does have an additive inverse, and it would just be its opposite. Over here, we're asking, is there something we can multiply by A to get back to its inverse? And it has to be the same thing that we would multiply on the other side to get back to its inverse. And so, in fact, there is such a thing, and we're gonna call it A inverse with that notation. And again, this you're gonna have to sort of stay tuned for a future video to learn more about. But matrix multiplication does have an inverse and an identity. And actually, I'm noticing a typo here. I did not mean inverse here. I meant identity here. Sorry about that. Okay. So stay tuned for more information about matrix multiplication.